Ever open Netflix and feel like it literally read your mind? Or maybe you've watched a self-driving car navigate a completely chaotic intersection and thought, how on earth does a machine actually know how to do that? The truth is, we're completely surrounded by the real-world impact of artificial intelligence. I mean, from the targeted recommendations on your favorite shopping app to drones making automated deliveries, AI is reshaping our world at an absolutely astonishing pace. But for a lot of us, looking at this massive technological revolution kind of feels like standing at the bottom of an unscalable mountain. You look up at Mount Data and just feel overwhelmed. Well, today we're going to change that. Welcome to This Explainer. Think of this as your ultimate guide to demystifying that climb. We're going to map out the exact route you need to conquer Mount Data and build a resilient, totally future-proof career. When you look at all these incredible technologies, it's so easy to feel a bit intimidated. You might be sitting there asking yourself, okay, but what does it actually take to build the AI of tomorrow? Do I need to be some sort of certified genius? Listen, I totally get that feeling. But let me reassure you right now, you absolutely do not need a PhD in advanced mathematics or computer science to start this journey. Not at all. What you actually need is a structured blueprint. You need a clear, step-by-step path that just cuts right through the noise. And that is exactly what we're going to build together today. Okay, let's dive into this. Here is our strict, chronological map to organize the chaos. We'll be hitting the data science revolution, programming and pre-processing, mathematics and visualization, mastering machine learning, deep learning for 2026, and finally, some pro tips for success. First up, Phase 1, the data science revolution. Over the last decade or so, this whole field has just exploded across healthcare, fintech, big tech, you name it. But what actually is it? Basically, data science is the intersection of math, data, programming, machine learning, and deep learning all working together to build useful stuff. Notice the word data sitting right there in the center. Without the raw fuel of billions of real-world data points, literally none of these modern applications would even exist. Data is the foundation of the whole shebang. Moving right along to Phase 2, programming and pre-processing. Before you can build an AI brain, you obviously have to know how to speak to the computer. And when you look into this, you'll generally see two main language options, Python and R. So the crucial point is, you should absolutely choose Python. It's incredibly popular, exceptionally easy for beginners to pick up, and, most importantly, overwhelmingly demanded by employers for AI engineering right now. But once you start using Python, you're going to discover a hard truth. Real-world data is a total mess. We're talking missing values, weird errors, formatting issues everywhere. You can't just feed that raw garbage into an AI model. You have to clean it up first. This is exactly where two essential Python libraries come to the rescue, NumPy and Pandas. NumPy handles the heavy numerical computations super fast, while Pandas is built directly on top of it, giving you the absolute essential tools you need to pre-process and clean up that data. All right, Phase 3, mathematics and visualization. Now, I know what some of you are thinking. Uh-oh, here comes the math. Well, let me stop you right there. Your 10th grade math is honestly enough to get started. It's all about intuition here, not rote memorization. There are really just 4 pillars you need to grasp. First, statistics. You know, your mean, median, mode, and variance. Second, probability. Third, linear algebra, basically understanding vectors and matrices. And finally, calculus, specifically differential calculus, like just understanding what dy over dx actually represents on a graph. Master the basic intuition behind these 4, and you are golden. But numbers alone aren't enough, right? You have to be able to explain your findings. You've got to show those brilliant insights to non-tech managers or teammates. That's where data visualization becomes absolutely vital. You're going to use 2 key Python libraries for this. First is Matplotlib, which is perfect when you need low-level exact control over literally every pixel of your chart. The second is Seaborn, which is just fantastic for quickly whipping up beautiful statistical plots with very minimal code. Together, they are the perfect duo for telling a visual story with your data. Now we're getting to the really fun stuff. Phase 4, mastering machine learning. This is the true core of AI, where algorithms use data to make predictions without us having to explicitly program every single rule. It all starts with supervised learning. This is where you use labeled data with predefined outputs to train your algorithms. Think of a healthcare company, for example. They already know which past patients were healthy and which were unhealthy. You feed that perfectly labeled history into the algorithm so it learns the underlying patterns, and bam, now it can classify future patients. It's like giving the computer an answer key to study from. And this brilliantly illustrates the flip side when we look at unsupervised learning. In unsupervised learning, your data has 0 labels, nothing. The The algorithm is just handed a massive pile of patient information with absolutely no idea who is healthy or sick. Its job is to dive in, find its own hidden patterns, and group people together, maybe clustering all the older patients over here and the routine checkup patients over there. It wonderfully finds structure in the chaos completely on its own. The third flavor is reinforcement learning. The source material uses an absolutely excellent analogy here. Reinforcement learning is very similar to training our pet dog. Just like you'd give a dog a biscuit for sitting and withhold it when they don't, we train algorithms by playfully offering digital rewards and penalties. Through trial and error, the algorithm figures out how to perform incredibly complex tasks just to maximize its biscuits. To actually build these models in the real world, you need a highly practical toolkit. First up is scikit-learn. This is going to be your absolute primary machine learning library in Python. Next, SQL. Companies store their massive datasets in giant relational databases, and SQL is the exact language you need to fetch that information. Finally, Git and GitHub. This is all about version control, allowing you to track your changes and collaborate seamlessly with other engineers without breaking the code.
Next up, Phase 5, Deep Learning for 2026.
Deep learning used to be kind of an optional bonus skill, but with the high competition expected by 2026, it's a baseline requirement. Now, what's really interesting about this slide is how this whole concept takes inspiration directly from our own biology. Deep learning relies on artificial neural networks, or ANNs. These are intricate digital systems designed to explicitly mimic the billions of interconnected neurons firing inside the human brain. By layering these artificial neurons deeply, the machine can learn incredibly abstract and complex things from the data. And just like biology, there are different brain structures for different tasks. You'll need to learn about CNNs, which are specialized for extracting features from images and video, absolutely essential for stuff like self-driving cars. Then there are RNNs, designed to process sequences like text, and of course transformers. These are truly incredible. They're the architectural marvels powering modern generative AI, like the massive language models we interact with every single day. Oh, and a quick tip. When building these advanced systems, it's highly recommended to use the PyTorch framework over TensorFlow, as it's pretty firmly become the standard for modern AI development. Finally, we reach Phase 6, Pro Tips for Success. Knowing the theory is awesome, but how do you actually turn that into a lucrative career? Here is your 3-step strategy. Step 1, you must build and deploy projects. Theory isn't enough, you need tangible proof of work. Use platforms like Kaggle to find datasets and deploy your models using tools like Streamlit or Hugging Face. Step 2, target a domain specialty. If you learn to apply AI exclusively to finance or defense, you become incredibly valuable to companies in those specific sectors. Step 3, if you're a fresher just starting out, please learn basic data structures and algorithms. Understanding time and space complexity proves to employers that you actually know how to write truly efficient code. Let's ground this entire journey in reality for a second. 4 to 6, that's the number of months it will realistically take you to master this roadmap and be job ready. But there is a catch. That timeline assumes you are dedicating about 3 to 4 hours of focused, consistent study every single day. It requires hard work, for sure, but the timeline is finite. It is an incredibly achievable goal if you just stay disciplined. So, there we have it. We've laid out the entire path, from simple variables all the way up to complex artificial neural networks. The mountain has been mapped. The roadmap is undeniably clear. The only question left is, are you ready to take the first step? Challenge yourself right now to stop feeling overwhelmed by the technology of tomorrow. Prioritize your career, especially if you're in your 20s or early in your professional journey. Don't sit around waiting for the perfect moment. Open your laptop, start learning Python today, and I will see you at the top of Mount Data.